Hello everybody, and welcome to yet another installment of Rockin' with Ratios. We are going to be looking at percent discount today and how we can use percent bars and ratios and proportions. Whoops, focusing, fuzzy, in, out, come back. Oh, there it is, lovely. Okay, so how we can use percent bars or ratio tables to help us solve percent discount problems, because percent discount problems are some of the most common problems that you're going to see in everyday life. And so being able to solve them is very, very handy. Okay, so first, just a reminder, a percent is a part to whole ratio out of 100. Okay, so a sweater is regularly $32. It is 25% off the original price this week. Okay, so the sweater would normally cost $32, but this week you get to take 25% off. So the first question, would the amount of the shopper save be considered the part, the whole, or the percent? Okay, well, let's look at the information we have, right? This is the regular cost of the sweater. Like if you paid all the money for the sweater, normally it would be $32. So if you're looking at the whole price of something, that would be the whole, okay? And 25%, right, is obviously the percent because it's 25%, right? So the amount the shopper saved is a part of that whole $32. So the part that the shopper saved, that 25%, whatever that money is, that would be considered to be part of the whole. Okay, so now let's look at how much they would save by buying the sweater this week. It says show two methods for finding your answer. I want to start with doing a percent bar. Okay, so draw yourself a nice percent bar. If I haven't drawn it for you already, which I might do. Okay, so there's our percent bar. And as always, right, we have 100% at one end. We have 0% at the other end. We know that 100% of this sweater is $32 because that's what it's normally costing. And 0% would be $0. Okay. And so 25% off this week, right? 25%, one of our really easy percents to work with because 25% is a quarter of 100. So I'm going to break my percent bar into quarters. Okay, so that would be 75%, 50%, 25%. Okay, so I'm going to start with my nice easy benchmark of 50%. 50% of 32 would be $16. Okay. And 25% then, which is the percent I'm really looking for, 25% is half of 50. So half of 16 would be $8, right? So I don't even need to fill out anything else, right? I have discovered that 25% of $32 is $8. So I would have an $8 discount. Okay, so how much would a shopper save by buying this sweater this week? If it's 25% of $32, that would be $8 saved. Okay, so if I wanted to do that with a ratio table instead of a tape diagram, right? I'm just going to erase this to make some space. I need to know, okay, what is 25% of 32. So I'm going to put P and W for part and whole. Right? I'm starting out with the information I have, which is 25 out of 100. That's my percent. So I'm looking for what 25 out of 100 would be if my total cost was $32. Now, this is one of those cases where the ratio table isn't really all that nice because getting from 100 to 32 isn't that fun, right? We can figure it out by saying, okay, well, 100 divided by 32 is 3.125. So that would be divide by 3.125, which means up here I'd also have to divide by 3.125. And 25 divided by 3.125 should give us an answer of $8. So 25 divided by 3.125, yes, does give us an answer of $8. So there's two ways to find the amount saved, okay? The second question, or the third question actually, is what would the shopper pay for the sweater? Well, working from part B, we know they're going to save $8, right? You found 25% of 32, which is $8. So if the original price was $32 and I'm saving $8, then I can just do 32 minus 8 is $24. Okay, that's not 24%, it's $24. Okay. Now, however, I also want to show you, using the tape diagram that you already have above, another way to think about this problem, which is that 25% off is the same as 75% on. Okay, what do I mean by that? Okay, I mean is if you take 25% away from $32, if you take 25% away off, that is the same as having 75% off on. So if I'm taking 25% off, I get to 75%, which is the same as, if you think about it coming this way, it's the same as 75% on. So this is off, working from the top down, and this is on, working from the bottom up. So 25% off is the same as 75% on. So what does this look like in terms of a tape diagram? Well, I've already got the tape diagram up here above. So, just going to erase this for a second. We had already determined, right, that if we laid out 32 as the whole, 50% would be 16, 25% would be 8. Now, so if I go up by steps of 8, 16, 75% on would be $24, right? Which is, as you notice, the same thing that we got down here, right? So 32 minus 8 was 24. We found the 25% first. We found it was 8, and we subtracted from 32. Or you can think of it as, I'm just going to take the 25% off and think of that as 75% on, right? If I know each of these is $8, I just have to build up to my 75%. So 8, 16, 24, and 75% on, which is the on price, okay, is $24. So 25% off gets you to $24. 75% on also gets you to $24. Okay. Two different ways to think about that problem. So let's look at another one. A pair of jeans was 30% off the original price. So now they've already taken the 30% off, and the sale resulted in a $24 discount. Okay, so that 30% off was equivalent to $24. So is the original price of the jeans considered the part, the whole, or a percent? Well, 30% would be our percent, and 24 is just the discount, right? It's just part of it. We don't know the whole thing yet because they're looking for the original price, right? The original price would be the whole price. So that was original before the discount. So the original price in this case would be considered the whole, right? So what was the original cost of the jeans before the sale? So let's start again with the tape diagram, or percent bar, whatever you want to call it. Draw a nice percent bar out here if I haven't done it for you already. Right? So there's our percent bar. And as always, right, 100%. Now in this case, we don't know what the 100% was. That is the original price, okay? And we don't, well, we know that 0% would be $0. What we do know is that 30% was a discount of $24. Okay, so I'm thinking 30%. You know what I'm going to do? 30%, that's a multiple of 10. I'm going to split my percent bar into tenths. I'm going to start by splitting in half, and then I'm going to split each of those into 5, each of those, and that one into 5 as well. So now I've got 10%, 20%, 30%, 40%, 50%, 60%, 70%, 80%, 90%, and 100%. Okay. So a pair of jeans was 30% off the original price. Okay. And this was a $24 discount. So 30% off, right, going from here to here is 30%, right, 100%. And this was equivalent to $24, okay? From there to 100% to 70%. And I've got 1, 2, 3 sections that cover that $24. So each section is representative of $8, right? 24 split into 3 would be $8. Okay. So I now know, it's kind of like our tape diagrams, I know if one box is 8, every single one of these boxes is 8. Okay. So what would the whole price of the jeans be? Well, 8, 16, 24, 32, 40, 48, 56, 64, 72, 80. 10 groups of 8 would be $80. So we have found the full price, or the full original price of the jeans. I'm just doing a quick little check, right? Because 30%, remember we said, was $24. And we did it by figuring, okay, let's look at what 30% off is. But 30% here should also be $24. And is it? 8, 16, 24. Yes, it is. Okay, so that's just a quick check to make sure that our math is lining up. So what's a different way to do this problem? Well, we can do our ratio tables as per usual, right? And we've got, because we're dealing with part and whole, right? So in this case, we had 30%, which would be 30 out of 100. And we didn't know what the original price is, but we know that 30% would be $24. Okay. So what does that get us? This is really tricky to do, right? Because we're going from 30 to 24. So 30 divided by 24, 1.25. So we have to divide by 1.25 to get here, right? So I would have to divide 100 divided by 1.25. And what do I get? $80. So divide by 1.25. For this particular problem, I really kind of like the tape diagram better. But as I am all about multiple methods, if you like the ratio table better, go for it. Okay? So those are some looks at some percent discount problems and how to use percent bars and ratio tables to solve them.